Hi, this is the notes we went over today on how to do angled projectiles, and this is going to be the key for this. If you see on the first one, it says a kicker on a football field kicked the ball with an initial velocity of 25 meters per second. So just remember that is your initial velocity. That is the resultant velocity. That's kind of what I've been calling that one. It's happening at an angle of 30 degrees to the horizontal. So if you want to draw this out, it's going to look, let me start way over here. It's going to look like this. So if you have your y-axis, your Vy, and you have your Vx, your x-axis, well, this vector is actually 25 meters per second. And this is your, now you have a right triangle. And the angle, your theta right here, is 30 degrees. Okay, so now we need to know, that's the next piece of information there. How long was the ball in the air? So we were trying to figure out how much time the ball was in the air. Well, keep in mind that when we solve these problems and the formulas that we were using, it is good for half of the trajectory. So all of those four problems that we were talking about before are only good for half of your trajectory. So when this ball is released, this is my football right here, and it goes up, 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 and down, 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 down. So the problems that we find basically are getting your dy from here to here. Your remember your final velocity y is 0. Your initial velocity y should equal your I guess your y min should equal your y max over here. So you're basically over here. We need to figure out what our Vy is. Okay, we don't know. We were given our resultant. That's what they give us when they said 25 meters per second. So last thing I want to point out to you, remember your time up equals your time down. So when we solve for our problems, we're usually the equations only give us that time, and when we solve our problems, the equations only give us the dx up till right here. It's the same thing pretty much as when you do your up-down equations. Remember how it only gives us, the equations are good for half of the trajectory. So anyway, I just want to point that out to you, that really this is t gives us just to this top point right here, and dx just gives us to this point right there. Okay, so back to our, what do we know, our list, if you will. We know that our final velocity is going to be 0. We don't know our initial velocity y just yet. We don't know our time, and we do know that g equals 9.8 meters per second squared. Okay, don't confuse this Vy right here with this initial velocity right here. This is a resultant velocity. Okay, so the first thing I'm going to do is try to figure out what my Vy is, and I can do that with some trigonometry. If I know that my angle, I'm searching for my opposite angle. So searching for the side opposite of the angle, and I have my hypotenuse, so that's your sa. So that means I can do my sine of 30 equals opposite over hypotenuse. My opposite is our unknown over my hypotenuse, which is 25 meters per second. I don't know why I went way over there. It seems like a waste of space. But anyways. So from that, you should be able to get that your Vy is, let's put it out over here, 12.5 meters per second. Now, if I really wanted to, I could have figured out my Vx over here. But looking ahead, I noticed that my next question was how high did it go? So I'm really concerned to begin with the y-axis. So here is how long was the ball in the air. So really it's not just time, it's how much it went up and went down. So it's 2t, and here I have dy. So now that I know my Vy, there is a formula I should be able to use in order to be able to figure out my time. So we're going to say, turning around, I'm going to draw out the entire equation this time, but I won't later on. That's when I see where I'm getting this. So from the four equations we've been working with, Vf equals Vi plus Gt. Okay, so if we plug in, we already said that the final velocity at the highest point in the trajectory, remember, it starts to slow down again. So the velocity is 0. So we can say 0 is equal to, and we've discovered mathematically that our Vy is 12.5 to try and find our time. Okay, so 12.5 plus a negative 9.8 times time. So negative 12.5 equals negative 9.8t, divide, both sides by 9.8. And your time it takes to get to the top of the trajectory is 1.28 seconds. You'll notice in the equation it says how long it was in the air. So we don't want this time up. We want to also add to that time down. So you just double it. And so for part A, you should get 2.6 seconds. That's how long the ball was in the air. Okay, so this is part A. And part B, I'm going to come over here. I did not give myself very much space, did I? So for part B, I am now looking for how high it went. Okay, so we're simply looking for our dy. So you're going to find that from gt squared. Okay, so we are going to find our dy by using this equation. I just want to caution you that you're using the correct time. Remember, your equations are all good for half of the trajectory. So we only need this original time, not the time doubled. We need 1.28 seconds. So equals times 1.28 squared. Don't forget to square that. And your dy should be about 8.2 meters. I'm going to box that around so my teacher does not get a wrinkle. That was part B. That wasn't very pretty because I am using a very tiny space to do this. So hopefully y'all are at least understanding the words that are coming out of my mouth. And then I sent you home with at least start number 2. Okay, this one, a soccer ball is kicked with a velocity of 6.3, so that tells me my resultant velocity. And it travels upward at a 25-degree angle, so that's my theta, to the ground. How long will it take to hit the ground? So that is 2t we're trying to find. And then it says here, how far down the field will it land? So we want to see total trajectory. So really you're going to double your dx. And then what will be the highest point? That is just your dy. Okay, so set it up. I'll make my picture bigger this time. My angle is 25 degrees. I'm not drawing at the scale, obviously. And it says my resultant velocity is 6.3 meters per second. So I need to figure out how far down the field it's going to land in time, all that kind of fun stuff. So we'll start with dy. You can use cosine if you want and do your, you can start out with your dx if you really want to. But let's do our dy for now and use sine. I'm doing opposite hypotenuse. If I was using cosine, I would be doing hypotenuse adjacent. So let's do our dy though. Start right here. Okay, so sine opposite is dy. I keep doing it. Okay. I keep doing it. Oh my goodness. Okay, so d. I did it again. Divided by 6.3. So you multiply 6.3 times sine 25. And I got 2.66 or 2.7 meters per second. And now that I know my dy, I can go ahead and find my time. Okay, if I go ahead and shorten this equation up here, by the way, once you start seeing me do this over and over again, and that's a 0, you can go ahead and shorten that. If you want to get time by yourself, that is the same thing. Okay, so we're going to go ahead and, if you want to just get time by itself, this equation right here equals this, because we have been putting 0 in for a final velocity and with the up-down projectiles. Okay, so now I'm just going to use that equation to shorten life. Okay, so VI we said was VIY, rather. 2.7 divided by 9.8. .28 seconds to make it up the projectile to the top is what I said, 0.28 seconds to make it to the top and then back down again. Do not forget to double it. 0.55 was how long it takes for it to hit the ground. Okay, so over here you can say TT is actually 0.55 seconds. Okay, so let's do part B. So that was A. Part B, how far down the field will it land? That is my 2dx. Remember, the formula is only getting us half of the trajectory. So how far down the field will it land? I have time, and when I do my time equation, I haven't done my dx yet, so let's go into our dx. I have two unknowns. That's unknown, and that is unknown, and that is not acceptable. So let's go find our vx real fast. You look back over here again. Your vx over here, it's adjacent, and you have your head pat. We'll also have that now. Solve for it. Let's be more accurate and use our given. So we say our cosine 25 is going to be adjacent over hypotenuse. So multiply those together to solve for Vx. .7 is our Vx. So now I can take my Vx and plug Vx in and T in to get my dx. 5.7 times, what is my time in seconds? Is it 0.55? No, don't forget I doubled it. My time is actually 0.28. So dx equals, we say 1.5. Am I done? How long, how far down the field will it land? Well, dx is 1.5, but don't forget we have to double it. So we have to say times 2. Highest point, now I'm looking for my dy. 1/2 gt squared. So I plug in my time back to my original time again, which I found to be 0.28 seconds. And so from here, dy equals 0.36 meters. That is it. We will go over this again, and might be a little bit more space on this one, but at least I circled the ones that we knew. So anyway, this is just an example of using your trig functions to help us find some of our knowns.